Hello friends, so in this video I am going to discuss about maxima and minima. So we have a function which is y is equal to x cube minus 3x plus 2. So let's begin. So we have y is equal to x cube minus 3x plus 2. What we can see here is as x changes, y changes. So y is dependent variable here, and you can see in the left hand side figure. In the left hand side figure you can see this function has been plotted. As the x is changing, we have the curve. So if x is equal to 1, we can see, so y at x is equal to 1, if you want to see, this will be 1 minus 3 plus 2, that is 0. That means here you can see that at this point x is equal to 1 and y is equal to 0. Similarly, if you want to see what is y at x is equal to minus 1, you can put the value of that. X is equal to minus 1, and you can see that what's the result coming. So this is equal to 4. From the graph it is very clear that these 2 points, this one and this one is maximum. This is the local maximum, you can see, and this is the local minimum, this one. We want to see, without plotting, we want to know these local maxima and local minima. So this can be done using differentiation, as I already discussed in the previous videos. What we will do is we will calculate the first derivative, dy by dx. So if you plot the dy by dx, calculate dy by dx of x cube minus 3x plus 2, that is dy by dx of x cube minus 3x plus 2. You can see x cube differentiation is 3x, 3 minus 1 minus 3, differentiation of x is 1, so into 1, and differentiation of 2 is constant, so differentiation of constant is always 0, so this becomes 3x square minus 3. Now to calculate maxima or minima, what we do is we equate dy by dx to 0 and solve this. If you solve this, you get x is equal to plus 1 or minus 1. So at plus 1 or minus 1 you can have maxima or minima. To see which one is maxima, we have to calculate the second derivative. So second derivative is d2y by dx2. If you calculate the second derivative of this one, if you calculate second derivative, this becomes 3 into 2x, okay, and 3 is constant, so this is 0. This becomes 6x. Now you want to see the value of d2y by dx2 at points x is equal to plus 1. At plus 1 this becomes plus 6, that is positive. So at x is equal to 1, this is minima. If the second derivative is positive, this is minima. So we can see in the plot also, which we have already seen. But now using the differentiation, without plotting the curve, we know that at x is equal to 1, it is a minima. Similarly, d2y by dx2 at x is equal to minus 1, sorry, this becomes minus 6. So this is negative, so this is the maxima point. So we can say that x is equal to 1, we have a minima, and x is equal to minus 1, we have a local maxima. So this is the process by which you can find the maximum and minimum of any function. And in machine learning, basically you use maxima and minima to see for the optimization of the loss function. So basically we use the minimization of loss function, and for that we can calculate the minimization using maxima and minima. Now if you want to know that how the differentiation of different functions has been calculated, you can see this equations. In the left, the differentiation of x is 1, differentiation of some constant times x is a will come out, and x differentiation of x is 1 again. Differentiation of x raised to the power n is nx raised to the power n minus 1. Differentiation of cos x is equal to minus sin x. You can get this in the Google. If you search the list of formulas for differentiation, you will get it. So like this you can calculate the maxima and minima of any function. So this is all about in this video. I will be talking more about in the next video. Thank you.